Okay, so good day to our grade 8 math science high school learners. For today, we are going to continue our discussion for the third quarter. This is going to be our third lesson on basic proportionality theory. Okay, so let's try to read this problem. In the diagram below, part ST is a right angled triangle with a right angle at S. X and Y are midpoints of RS and ST respectively. So we need to find a value for this problem. What is the value of quantity ry squared plus quantity xt squared plus, all over xy squared? So how will we solve this problem? Okay, so let's try to look at our givens. For our first given, it says here that we have a right angled RST. So that means if this is a right angle, so therefore triangle XSY is also at right angles. Okay, so we also have triangle RST as a right triangle. And we also have triangle RSY as a right triangle. Now these are all right triangles. Okay, so let's try to check again. So we have RSY, then we have XST as well. XST is a right triangle. We also have, yes, RST here, and then we also have XSY. Okay, so what we're going to notice in all of these four triangles, since this one was repeated, all of these four triangles have the same vertex at the center, so that is point S. So therefore, they're all right triangles. And what do we say about right triangles? Right triangles are similar. Okay, they have similar side measurements. Now, if we have right triangles that are similar to each other, that means we can use this formula in trying to find the value of this given expression. Now, if you recall the theorem that we mostly use in finding the side measurements of a right triangle, so that will be the Pythagorean theorem, right? And for this case, we will be using the Pythagorean theorem. Okay, so how will we use the Pythagorean theorem for this problem? So let's try to go to ry squared first. So what is the value of ry? So ry here, it's this hypotenuse of rsy. So therefore, ry squared is equal to rs squared plus sy squared using the Pythagorean theorem. We also have xt squared, and that's equal to what? So xt is over here. That's equal to xs squared plus st squared. We also have xy squared. What is the value of xy squared using the Pythagorean theorem? So we have xs squared plus sy squared. Here we go. Now that we have these expressions, let's try to plug it in this formula. So since ry squared is equal to rs squared plus st, wait, this should be st. Rs squared plus st squared. Oh wait, ry, right? Rs and then oh wait, I'm sorry. So this should be sy. Wait a minute. So this should be sy. Okay, so plus sy squared. So therefore, we're going to put here for ry squared plus xt squared all over xy squared. Or maybe we could just put it here at the bottom. We have ry squared plus xt squared all over xy squared. So the value of ry squared is rs squared plus sy squared. We also have plus the value of xt squared, which is xs squared plus st squared. And all over that, we have here xy squared. And xy squared is just equal to xs squared plus sy squared. Okay, and since it was mentioned in the given that x and y are midpoints, so that would mean, for our problem here, if x and y are midpoints, therefore Rx and xs are congruent. Okay, so Rx and xs are congruent, and we can say that sy and yt are congruent. Now, if they're congruent and the value of Rs here has been given, so therefore Rs could be equal to 2. It could be equal to 2 sx or xs squared plus sy squared plus, okay, plus sx. Okay, so xs and xsx is just gonna be the same, plus sx squared plus 2 times sy squared all over sx or xs squared plus sy squared. Now, what we can do here for this problem, so we can try to simplify this. So that would give us essentially this value over here. So that's sy squared plus sx squared all over sy squared plus sx squared. So this gets canceled out, and what we're left is 2, okay, times sx squared plus 2 times sy squared all over sx squared plus sy squared. So we can factor this out. If you factor that out, so that should give you 2 times quantity sx squared plus sy squared. Okay, and 2 plus 2, so that should give us 4. And we have here a value of 1 all over sx squared plus sy squared. Now this gets canceled out, and that should give us 4 plus 1, and that should give us 5. So therefore, the value of quantity ry squared plus xt squared all over xy squared is just equal to 5. Using grouping, factoring, and cancellation, and of course the Pythagorean theorem for this problem. And that's how we can solve this problem.